Unit 3 is all about exponential and logarithmic functions. So starting off with the first one, exponential functions. So in this chapter, you're going to study two types of non-algebraic functions. We literally just said that. So if you haven't figured it out already, it is exponential, exponential. I shouldn't spell out loud, and logarithmic. So they are non-algebraic. In other words, you're going to have variables in there, but they're not going to be like x to the second. In fact, it's going to be a little bit different. Instead of the exponent of 2, we might have an exponent of x. So the definition of an exponential function, f with base a is denoted as f of x equals a to the x, where a is greater than 0 and a is not equal to 1 because 1 to any power is always 1, and x is any real number. So we're going to graph two different functions in the same coordinate plane. One of them is f of x equals 2 to the x. The other one's going to be g of x equals 4 to the x. So for 2 to the x, let's make a quick table and we'll see if we can do some of this by hand. Let me switch to this. So we're going to plug in some x values. We're going to get some y values out of it. So let's just do the -2, -1, 0, 1, 2, the ones we've been using for a bit. Now when we plug in -2, we'll do 2 to the -2. Which, if you recall correctly, is the same as 1 over 2 to the second. In other words, 1/4. So at x equals 2, we're at a y value of 1/4. So that's not very, or sorry, x equals -2, we're at a y value of 1/4. It's not very high up. For -1, so I'll do 2 to the negative first, which is the same as 1 over 2 to the first, or 1/2. So at y, or x equals -1, which is a little bit higher. 2 to the 0. Well, anything to 0 is 1. So 2 to the 0, 1. 2 to the first is just 2. So we'll plot that at the coordinate 1, 2. And then 2 to the 2 gives us a y value of 4. Now this pattern is going to keep on going forever. So it's going to keep on going up and up and up and up. If you were to do 3, it'd be 2 to the third, which would give you 8. Just adding another point to get a little more accuracy. Now the left side of the graph is going to get really, really close to the x-axis, but never quite touch it. And we'll draw an arrow going that way. Now for g of x, 4 to the x, let me switch colors here. Make an x and y chart again. X, y, we'll do -2, and let's just do that first so we have a little bit more room. We got 4 to the -2. Following the same pattern, it's 1 over 4 squared, which is 1 over 16. So that's really small. 1/16 is even lower than that point. So if you can draw it a little lower than that point there. Let's see, -1 is 4 to the negative first, which is 1/4. So that's just that's halfway or half as high as the other point that we had there on the red graph. Plugging in x equals 0, we got 4 to the 0, which is 1. So that's going to share the same point. 4 to the second. Or sorry, 4 to the first. Getting a little ahead of myself. Wow. 4 to the first just gives us 4. So we plot that on the graph. We're up here. And then we'll do 4. Nope, man goodness. Plugging in 2, sorry. We got 4 squared gives us 16. That's going to be off our graph. It's going to be way up here. It's not super accurate there. But if we graph this, it's going to skyrocket over there. And on the left side here, just like in the previous example, you can get really, really close to the x-axis. Technically closer, faster than the other one, but it's never going to quite get there.